Hello, I'm Mr. Howard Yu. I'm the author of this Mastering P5 PSLE Science OEQ Investigative Reasoning book, which I have published last year to encourage students to master in their answering for open-ended questions. So in this book, actually, there's one interesting topic which I integrated. If you could remember, last year during the circuit breaker, Singapore hit a record high numbers of dengue cases, which I like to showcase to you in one of these interesting proposal to the Ministry of National Environment. As you can see on page 78 of this book, I've extracted a chart or a graph showing the dengue cases in Singapore in the year 2020. So you can see here there were 137 dengue cases reported in the week ending 20 June 2020. So it is 20 June 2020. And this is the record number of dengue cases in Singapore. And during that time, it was projected to exceed the previous high. And indeed, it exceeded the previous high. So, as a science teacher, I've taught students that actually we can use certain knowledge in science in our daily lives. So, what I did was actually on page 79, I written an interesting email to the minister, who is Dr. Vivian Balakrishnan. Although he is the Minister of Foreign Affairs, but he's very familiar with the environment because his previous portfolio was the Minister for National Environment. And then I told him about my idea, and my idea was to use dragonflies as a biological agent to control the number of mosquito, which actually mainly targeting at those mosquito which spread the dengue fever. So I'm very glad that Dr. Vivian Balakrishnan replied me on the 29th of June in a so-called during that time was a confidential email. And this is part of the email he replied. He said, "Dear Mr. Yu, thank you for sharing this fascinating idea. And this idea was using dragonflies either in Singapore or imported from our neighboring countries because those dragonflies, I believe that are from Vietnam, they are more capable in decimating the mosquitoes population. So this is one idea. And I like to share with you and even the students these true capabilities of the dragonfly in terms of its kill rate and also in terms of its vision and also flight ability in some of these videos which are extracted from YouTube. So be patient and let's continue in watching.
Forget a stalking lion or hungry shark. In nature, there's nothing scarier than a dragonfly deciding you're its next meal. That's because, according to new research, dragonflies nail their prey up to 95% of the time, trouncing the anemic kill rates of other top predators. A dragonfly swoops through the air to catch its prey midair, tear it apart, and immediately begin the search for their next meal. Several new studies point to brain, eye, and wing coordination that allows dragonflies to fix on a single insect in a fluttering mass, and surprise attack it at speeds up to 30 miles an hour. It rarely ends well for the insect. Why the sudden interest in dragonflies? Much of the research is supported by the US military, which, the New York Times reports, sees the dragonfly as the, quote, archetypal precision drone.
As you can see here in this video, they talk about the dragonfly with very good brains that is being the neurons connected to the eyes, to the wings, to allow it to hunt its prey so well. Let's continue to see the next video. In this video, which I've extracted from a YouTube channel of the BBC Earth, you'll be able to see how the dragon eye's compound vision is able to track and also respond to small particles which we use to simulate like mosquitoes or flies.
This pea shooter might be low tech, but it's the perfect tool to recreate a high-speed target for our dragonfly. It fires out seeds so quickly, our eyes can't possibly see them. But is the dragonfly's vision quick enough to spot it?
Observe. Taken by a high-speed camera.
We're going to have a look back at our slow motion clip.
Will the dragonfly detect the tiny pea?
The dragonfly is completely still. And the head definitely turns before we see the seed come into frame. And then the dragonfly almost takes off, but it has enough time to assess that it's not a fly, and it changes its mind and stays on its perch.
Slow-mo. Observe.
That's incredible. The head definitely moves first.
The dragonfly's vision is so quick, it can track the flying object and work out it's not prey, all in less than 5/100ths of a second. It's partly due to the speed at which they process information. Dragonflies experience time in a completely different way to us. They have a reaction time of 30 milliseconds, far faster than ours. The whole process of seeing a fly, taking off and catching it can happen in about the same time it would simply take us to react in any way.
Next, you will see a simulation of how the dragon's eyes be able to see fast movement in this flicker book as I continue the video.
The images begin to animate. And that's because the pages are moving so fast we hardly notice them turning. It's essentially an optical illusion.
Although our vision appears to be seamless, our eyes actually work by capturing up to 60 images a second. Our brain then combines them to create the illusion of a continuous, moving image. Because the pages are turning faster than that, it brings the animation to life.
To a dragonfly, however, this would look completely different.
The images would appear slowed down, and it would see each individual page turning.
And that's because dragonflies see faster than we do.
Whereas we see 60 images per second, they see around 200. And so they can observe things that are just too fast for even us to process.
So this is one way how the dragonfly is able to see. And next we will see the next part of the dragonfly's ability in the next video. And this website actually explained to you that actually dragonflies are the acrobats of the sky. They can fly upside down. They can turn 360 degrees on a dime. They can fly more than 55 kilometers per hour. Indeed, I told my student that the dragonfly is actually the fastest flying insect. No insect can fly faster than a dragonfly. But however, although dragonflies, they are good so-called in terms of pest control, but birds, they like to eat dragonfly. And actually most birds, they do fly faster than dragonfly. So there are more than 40 dragonflies in the wild. And in this video, we can also see how the dragonfly can fly backwards. Let's continue with this video here.
Fly upside down, hover, turn 360 degrees on a dime, and reach speeds of up to 55 kilometers per hour. They can even fly backwards with as much skill as they fly forwards. Now researchers have figured out how. Scientists captured over 40 dragonflies from the wild and placed dots along their wings for tracking. They then recorded their flight with high-speed cameras. When the scientists analyzed the videos, they discovered backward-flying dragonflies angle their bodies upward at a 90-degree angle to the horizon.
As you can see in this video, they angle its body 90 degrees. That means it's perpendicular as it moves this way. That's why it can fly backwards. Let's continue.
This changes the direction of force generated by the wings through whole body rotation, instead of only changing the way their wings are oriented. This style of flight, used sometimes in helicopters, was found to be surprisingly aerodynamic in dragonflies. When moving backward, the dragonfly's wings can generate force as high as 2 or 3 times the bug's body weight. This work may help engineers design more acrobatic aerial robots, even backward flying ones.
Thank you for watching the video. So once again, I like to invite students to explore science, be inspired by joining one academy, and be coached by Mr. Howard Yu. I believe I can help students to appreciate the science around us, and also more importantly for parents, be able to motivate them to enjoy, and they can be self-motivated in answering open-ended questions. So I wish you all the best in your science journey or your voyage with me in one academy as we sail beyond the horizon over there. Thank you and God bless.